Okay. A very good morning to one and all present here for this 1 week online international training program on agriculture 4.0, precision and automated agricultural technologies. First of all, I have three important announcements before we start the session. The participants who have not joined by their name are requested to rename themselves because it is important for recording your attendance during the session and also to recognize the registered participants. So if joined by other names, you will be removed. Secondly, if you have any query or questions related to topic during or at the end of the lecture, you can write those in the chat box. So we shall open the chat box towards the end of the each lecture. And please register yourself for posting unwanted messages like good morning and other messages. And thirdly, we shall post one short assignment on WhatsApp group at 6 p.m. Indian Standard Time. All participants are requested to submit the assignment on time and as per the guideline issued on WhatsApp group. And please note that responding to this assignment will be considered for issuing the certificates to participants. So we are in the 5th day, and that is last day of this training program. And today we are having three sessions. In first session, we have with us Ms. Momtanu Chakraborty, technical support engineer, Pix4D North America. On behalf of CAST project of Mahatma Phule Krishi Vidyapit Rahuri, I extend warm welcome to you.
Thank you so much.
Okay, thank you, ma'am. I also extend warm welcome to Dr. Sunil Gorantiwar, sir, co-convener of this training program and principal investigator of CAST project. I also welcome Dr. Mukund Sinde and Dr. Sachin Nalode, sir, organizing secretary of this training program. So thank you very much. And now I would like to request Dr. Mukund Sinde, sir, organizing secretary of this training program, to introduce Ms. Momtanu Chakraborty, ma'am, to our participants.
Yeah. Thanks, Deshmukh. And hello, Momtanu Chakraborty. Good morning. And on behalf of the Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture and Water Management, and also from our university, Mahatma Phule Krishi Vidyapit Rahuri, I very heartily, warmly welcome you for this your lecture on this in this training program. And I also appreciate your acceptance and your presence for this training program. And for the information of all the participants, Ms. Momtanu Chakraborty is a remote sensing engineer based in San Francisco and is currently working at Pix4D. She is experienced in 3D TOF sensors, LIDAR, 3D camera, aerial, that is multispectral and thermal, and satellite data applications in agriculture. She is passionate about precision agriculture, remote sensing, GIS, and she is helping people to overcome obstacles related to aerial imagery. Momtanu has a bachelor's degree in agriculture engineering and 2 master's degree in geoinformatics and natural resources engineering from Indian Institute of Technology, Bombay, and agricultural engineering from Washington State University, Pullman. So welcome, ma'am, and I request you to start your lecture.
Thank you, Dr. Shinde, for introducing me. So I'll share my screen. Hello, everyone. So as Dr. Shinde already introduced, I'm working at Pix4D and I'm currently based in San Francisco. So I did my bachelor's in agricultural engineering from Bidhan Chandra Krishi Vishwavidyalaya in West Bengal, India. And then I went to IIT Bombay for a master's in geoinformatics. And then I was working with Dr. Lovecoat. I did master's with him in precision agriculture. So today we'll be talking about decoding drone imagery with Pix4D. So I'll give an overview of Pix4D. We produce drone mapping and photogrammetry software tools, and it was founded in 2011. We have more than 200 employees, and our HQ is in Switzerland, and we have offices all over the world. So Pix4D, as I said, we make photogrammetric tools for drone images so that you can create 3D maps from those 2D images or the whole stitched map, which is called the orthomosaic. And it's used in a various number of applications like surveying, construction, agriculture, which we are going to talk about today, public safety, mining, inspection, etc. So I would like to talk about our products a little bit. Uh, the product, the first product we had and we still have is Pix4D Mapper. So Pix4D Mapper is actually software which can be used for all applications. But then recently we decided to verticalize into more products so that each product can be used for a certain applications. So the user interface and features are also a lot easier for the users to understand. And also a construction worker doesn't get features that is needed in agriculture because it's of no use. Pix4D Capture is one of our mission planning app, which is free. And you can plan the drone mission and take the images with this app. And Pix4D Fields is our software, which is solely based for agriculture. So today I'll be talking about Pix4D Fields. So since I'm talking about Pix4D, and today we are talking about precision agriculture, so I have to talk about drone imagery because Pix4D is based on drone imagery. So I think you have already, through all these lectures, you have understood why we use drone imagery. I would like to just say it again. So it bridges the gap between planting and harvesting. So farmers already use conventional methods in the mid-season to keep an eye on the crop. He walks through the fields and sees the plants if it has been damaged or anything. Then you can also use satellite images, but then the quality and resolution is limiting. Also, it depends on weather conditions like cloud cover, which drone images can overcome very easily. So you can actually understand the mid-season health of a crop. And crop changes over time, and you can understand the natural rhythm and make better decisions about seed placement, fertilizer application, etc., and prepare better for the future. So Pix4D Fields is a drone mapping software. It was built in 2018 and it's still evolving. It's very new, as I said, because Pix4D Mapper was developed in 2011. And then we decided to go vertical, and then this was released in 2018. And it's still evolving. We are adding new features every day, which are helpful for farm management. This software is available in Mac OS and Windows. So like you input any drone images, may it be a RGB image or multispectral image, and then we turn the drone images into actionable outputs designed for agriculture, and you can tackle the challenges in the field by converting those drone images to orthomosaic, vegetation index maps, zonation maps that can help you maximize the operational efficiency. So the unique points of Pix4D Fields is that it creates the maps very fast. You can get results within 5 minutes, which is very difficult for a photogrammetry software. Our previous software, Pix4D Mapper, the one we still have now, it takes maybe to stitch 200 drone images, it will take maybe an hour or so. But Pix4D Fields does it rapidly in the field. So you can make faster decision, and it doesn't require any internet. So you get the results in the fields. It is reliable because it doesn't depend on any satellite availability or cloud cover or anything. The results can be trusted because it eliminates the guesswork of the farmers. You are analyzing the crop maps, and you are measuring the issues using calibrated multispectral images or high resolution RGB images. You also stay connected because like you have a Pix4D software, you have your account. So with the same account, if you are logging into some other computer or other device, you can see your projects. So you remain connected, and also we connect to other platforms like John Deere Operations Center. So I'll talk about how the model looks like. So we are not service provider, we sell the software. People buy it, service providers, farmers, or anyone, uh, professors, universities. So universities mostly use it for research purposes, but service providers uh, use it to provide service to the farmers. So they go and talk to the farmer, plan the mission with the help of the farmer, because he knows exactly the part of the farm where you should fly. And then you go and fly, download the images, and process the images in Pix4D Fields, which will be done within 5-6 minutes. And then you look at the maps, the vegetation index maps, and the orthomosaic that is produced. With that, you see some hotspots, some areas, and then you work with the farmer to that place and identify the root causes of the stress. Maybe the area was over or underwatered, or there's an infestation problem, fertilization issue, or maybe you pull out soil samples and send them to the soil lab. Uh, so this is called digital scouting. So we don't replace scouting. It's just you see the maps, you understand the hotspots, the stressed areas, and you go and see the place. You don't have to walk through the whole field. You go to those positions and see what might be the cause of the stress. And then you till this you do in the field. After that, you can do this like stay in the field or go to your office and analyze the results a bit more, maybe get zonation map, prescription map, and then use it for variable rate application, fertilization for crops, and make other decisions. So the outputs that Pix4D Fields generates, this is not the full list. You can go to our website if you want that, but mostly it's the orthomosaic. By orthomosaic, I mean the whole map of the field. But there is a difference between orthomosaic and stitching. Like you are not just putting the images edge to edge and stitching them. Orthomosaic means you are removing the perspective distortions. You are creating that from 3D, like it goes 2D to 3D and then 2D. So you get accurate measurements. So whatever you measure on the map, that is actually the measurement on the ground. And you get field boundaries. You can draw field boundaries, then get vegetation index map, a digital surface model, zonation map, prescription map, about which I'll talk later. So what kind of drone images do we use in agriculture? So mostly it's multispectral images. We also use RGB images. Some people use thermal and modified cameras. So multispectral cameras have, in one sensor, there are 4 or 5 cameras. So each camera has one band. So you get several bands with one camera. So why do we use multispectral for agriculture? Because the colors we see in light, they are defined by the reflection of the light. So plants, they absorb and reflect light depending on that wavelength. So if you see the graph, you will see in the wavelength range after 700, which is the reddish and NIR, there is a big difference between the reflectance of healthy plants and stressed plants. So that enables, and with your eyes, you can just see the visible range, RGB. So with that, with the beyond the visible range, you are able to see that with the multispectral cameras, and then you can determine some damage or stress of crop before you can even see it, because sometimes when you see it, it's too late. You can do nothing about it. But if you get to know before that, okay, the crop is stressed, or it needs more water or fertilizer, or there is some infestation, you can take some actions beforehand. So it's not just multispectral images, because light, it's all light, right? And when you measure anything, whatever you're getting is reflectance. But then you need to compare it from day to day. So Pix4D Fields is like, we just don't focus on fast speed, but we also focus on radiometry and do a lot of research with that. So what is radiometry? So if you want to compare a map from, say, like today and in the next crop stage, the light is different, the sunlight is different. One day it might be sunny, one day it might be cloudy, but you want to be able to compare your crop. Like, there should be a standard or a reference. So that is why nowadays these light sensors are available and radiometric calibration targets. So these are your references and they help you correct for the changes in light. And so in this way, you can compare your maps over time, temporally, or even over areas. So what is a vegetation index? I'm sure all of you know it by now, but like, it compares two or it uses two or more bands and emphasizes the areas of different vegetative properties. So as you can see in the image here, uh, in the near infrared, the healthy plant is reflecting 50% of the light, and the unhealthy plant is reflecting only 40% of the light. But then this difference is very low, even with visible red. So these two differences, 30% and 8%, are not that much. But if you make it into a ratio or make a vegetation index, that helps you to see the variability better. So like the first vegetation index that was used previously was simple ratio, NIR by R, and later we came with normalization so that the difference is visible better. So all crops, so I'll give an example of this radiometry. So all crops change over time. Weather has an impact. Also, understanding the change can help us manage what we control, and it can help us prevent mistakes for the future. So when you see this image, it's an NDVI timeline of a wheat crop field. So you can see the NDVI of several crop growth stages, the timeline. So these have all been radiometrically corrected. So you can compare one map with the other map. So you can see that you can see how the crop growth is taking place. You can detect if there was some damage or some parts needed fertilizer or was infested in the middle growth stages, and you can take actions. You can also predict yield from these maps. And this is another index, NDRE, and you can see the timeline here. So you can see that, like, these both, the previous slide and this slide, both are index timelines, but in NDRE timeline, you're able to see that the variability in the later growth stages are better than NDVI. So the vegetation index you use, you have to decide that. It depends on the crop, the type of growth stage, and some other factors. But there are a lot of indices, and you have to select what vegetation index is the best for you. So from this, you can also do change detection. So from 11 June to 24 June, what was the change? So now I'll come to the more interesting part. I'll talk about some applications and use cases with Pix4D Fields. So precision agriculture is just the right input at the right time to maximize your yield and lower your inputs and avoid under or over supplying any input. So the applications are mainly scouting, drainage irrigation, insurance, fertilization, crop production, and crop protection. So as I was talking about scouting before, is just walking through the field to check the progress and look for pests, damage, anything, and then determine the root cause of that issue. Why scouting? Because as you all know, crop is a major investment. The input, it takes a lot of money, time, everything, and thus it needs to be checked. Uh, so pest, fertility, irrigation issues can be remedied if caught earlier in time, and it can also help prevent and plant future crops. So while Pix4D Fields is used for scouting, again we don't replace scouting. If you just see a map, you fly the drone and get your map. It's not that you see the hotspot areas, the lower NDVI, lower index areas, which means the crops are stressed, but you don't know the reason they are stressed. So you need to walk down to the field with the farmer and see and understand the reason, determine the cause. Uh, like maybe it's pest or maybe it's something else, and then take appropriate actions. So here is an image where it's a seed field, and it's an orthomosaic from Pix4D Fields for that. Uh, so this, like the farmer flew and then he found that, okay, these places, as it's marked, these are damaged caused by animals. This one, so you see, you just see the map, you don't understand what's the actual issue, but then the farmer will know, or you walk to that area of the field and you know it's poor soil quality. So you can see this is a corn field, and then you can the field is showing areas with poor soil quality. So you can see on the right side it's the NDVI map, and on the left side it's the orthomosaic. So you can see that with your visible eyes with RGB, you can see the differences, you can understand something is wrong, but then the variability or the detection is better with these multispectral images and when you create these indices. So again, like you see that these, you find these hotspot areas. The red spots means that it's, as you can see from the histogram below, it means lower NDVI. So you understand that something is wrong. This part of my field is stressed. So you walk there, and then you can maybe sample your soils, because it's like you think that your soil quality is not very good here. So you take soil samples from each of the place, and you can also annotate with Pix4D Fields. You can mark these places, also attach images, like you go and take image with your phone at those places and attach them in the project. So you can see that you can send these soil to samples to the lab, and then maybe understand what's causing the bad quality of the soil. Maybe it needs more potassium, more nitrogen. So you can assess the field, as I said. Uh, so each annotation, as you can see, like you can annotate and say, okay, this is maybe like you go and check each part of the field where the hotspots were there. And you can say that, okay, maybe I'm not sure of this part. So you mark it as not sure. Some you can say this may be a planter issue, this may be water issue. So you can mark them uh, for later. Another application that most people use precision agriculture for and Pix4D Fields for is drainage and irrigation. So applying the right amount of water to a crop is critical, depending on the crop stage. And certain crops also require drainage tile to be installed to remove excess water. Then certain crops require different types of irrigation systems to supply water and nutrients. So aerial maps are effective in planning drainage and irrigation systems. And so you fly your drones, and then with Pix4D Fields, you get very accurate maps, orthomosaic, and it's the manual labor is gone, and time is money sometimes, most of the time. So it's low cost. And NDVI maps then can be used to locate areas of drainage or irrigation issues and document improvements. So this is a use case from a soybean field in Iowa. So a farmer had hired a company in Iowa, a precision agriculture company, to see where the existing drainage tiles are located. So drainage tiles are extremely important because they help control the moisture levels, and they are significant investment for farmers. So knowing where existing pipes are, it can save growers a lot of money while ensuring optimal crop growth. So the team there was able to identify the drainage tiles, and the NDR index was did the best at it. And since the Reddit sensor, so this was done with the MicaSense Reddit sensor. I don't know if you've heard of it, but then MicaSense Reddit and Sequoia, these two are the most famous multispectral cameras. And so the team was able to spot the difference, and then they were able to so it was found that the plants on the top of the tiles, drainage tiles, were healthier than the crops that were far away from it. So here you can see NDVI map and NDRE map. So the RGB image, as you can see, it was not able to detect the drainage tiles, but the NDRE map was able to. So the drainage tiles, like one of the drainage tiles is marked. So they used this tool, and then they saw that most of the stress was occurring because the drainage was not being handled sufficiently. So the farmer understood where he had to install more drainage tiles. Crop insurance. So crops are major investments and should be protected with insurance products. So different insurance products, they protect different issues such as hail, flood, drought, fire risk. So why crop insurance? A proof of the event is required. So maybe your crop has been damaged due to storm or hail, but then the insurance company or the bank would require a proof. And so Pix4D Fields, with Pix4D Fields, you can just fly quickly and get the results. And then that would be a proof for the insurance, because the map will be showing all the areas of damage, and it will be detailed and accurate, even for area measurements. So with Pix4D Fields, you can measure areas in the map. So this is a field of one of my colleagues. So his corn was damaged due to storm, and so he is actually he's our colleague. So he works in Pix4D as a business development manager, but he's also a farmer in the US. So he had a short amount of time. So when, like, you have to apply for the insurance in a number of days. So he had a very short amount of time. He flew in that. So a lot of his crops were damaged due to storm. And then he used Pix4D Fields for processing and assess the crop storm damage. So as you can see, here NDVI map was used. Since NDVI is a good index, like it can also find bare soil. So here anything and like NDVI less than 0.25. 0.25 means very low NDVI. Like it's basically soil has NDVI like that. So anything less than that, he said that was crop damage, storm damage. So using the zonation, so we have this zonation tool, as you can see. So this is the part of the zonation tool, but on the right, you can see the prescription map. So in this example, you can see he put 100% in the red area, which means like it's totally destroyed. 100% on 8.5 acres. And other parts, the places that had a little bit more NDVI, he said that the damage was less. So he also made a record of the damage, but also how much damage for how much acre was done, he got that. So we have this comparison tool in Pix4D Fields, with which, like, sometimes if you just want to check, two maps, like maybe the orthomosaic, which is the RGB stitched map, and the NDVI, you can have two maps side by side and use the tool to check. Or maybe even bring in a map of another time, another growth stage, bring in that and compare with the map of now. So here you can see like those areas. This is a zonation map from Pix4D Fields. You can see there was total water damage at some places. So he said like he got more insurance for that because it was 100% damage. So underwater, total loss. And then you can also go and just take images in the field and attach them in the annotation. So when you ask for insurance, you like also have the RGB images of the field along with this map. Another application in precision agriculture is fertilization. Uh, so crops obtain nutrients from the soil, uh, but then grain harvest removes nutrient from the soil. There are some optimal level of macro and micronutrients for efficient grain production, and growers have to use various types of fertilizers and use it back on the field to replenish the nutrient level. And excess fertilizer is not economical. It's also not good for the crop. So yields often suffer various deficiencies in nutrients because of the fact that the fertilizers are not evenly distributed in the soil. So this also comes under soil sampling, as I was saying. The fertility varies based on soil chemistry, application methods, and water. And weather events can also impact fertility of soil. So again, why Pix4D fields? Indices such as NDRE, NDVI, and some other index, they show correlation with nitrogen deficiencies and plant health. So using zonation tool, you can also use the zonation and prescription map uh, as a variable rate application map for tractors. So this is the image of a winter wheat crop where each zones, like the whole field was divided into zones, and each zone was given a different amount of fertilizer depending on the NDVI. So another use case of fertilization is selecting soil samples. So here, potassium in carrot was determined with the images. So based on this NDRE images, two locations, soil sampling was done on two locations, one good, one bad. And then the soil samples from the lab, the analysis, it showed that there was a huge potassium difference between those bad soil, the soil taken from the red part and the soil taken from the green part. So fertilization recommendations can be used according to that. Because this part of my field has less potassium, this part has more. So you can do targeted fertilization and lower your fertilizer input. And also like that helps, that saves a lot of money, and it also reduces the negative impact of potassium percolation into groundwater. So it also saves the environment. So here, it's another example of variable rate application in winter wheat. So you can see on one side is the NDVI map, and on one side is the zonation map. So here, again, you created the zonation map, and then you know that, okay, the red area means the average value of the NDVI is 0.05, which means maybe the crop is dead here. So I don't apply anything here because like there's no use. The zone having a average NDVI of 0.10, I apply more fertilizer there. And I keep reducing the amount of fertilizer as I go to the greener colors, because I know that these places are already healthy. It's not stressed. It won't need so much amount of fertilizer. So this is called variable rate application. So in this way, you can reduce the amount of fertilizer and also uh, have a better yield. So here, this is a case of the same wheat field. It's 5.3 hectares. And here, it was just one application, 200 kg nitrogen per hectare. There was no variable rate application. The whole field had this rate of application. In this, what was done? It was divided into two zones, and in one zone, as you can see, the red zone means less NDVI. That means it's more stressed. Uh, so there, you give more fertilizer, and for the healthier zone, you give less fertilizer, and that reduced the input 22% compared to no variable rate application. Here, it's the same field again, but you divided your area into 5 zones from the NDVI map and made it an advanced variable rate. So for the 5 zones, you use totally different rates. Again, using the least rate for the greener zone, because that means that zone is already healthy. And using like giving no fertilizer at all, applying no fertilizer at all to the red zone, the small amount there, 0.1 hectare area, because this place, like the plants are already dead or damaged beyond control. So whatever you do, any decisions won't be able to help that place. So here, 27% input reduction was done compared to no variable rate application. Now we come to crop production. So Pix4D Fields is also used in crop production. So seeding or planting nowadays is sometimes done with drones, or you scatter seeds, or with tractors, or with planters. So it's important to know which part of the field is like determine the field or the status of the soil. Uh, so you can fly your crop quickly before or after seed planting to determine status. And then understanding the plant population and vigor, it can be indicative of potential yield. So after planting or mid-season, you fly again. So understanding the vigor from these maps, it can help you predict the yield. Then also using index maps, it can indicate potential issue that can affect crop production. So you can estimate crop production. And also, like if you see that maybe some part of the soil is not bad in the field, you apply more fertilizer there first, and then you start planting. So variations based on drainage or irrigation can be anticipated, and then more or less seed can be planted to reduce overcrowding plants. So here, as you can see, this is a pineapple field in Mexico. So the farmer contacted a service provider in Mexico. In Mexico, this place, it accounts for 65% of the national volume of pineapple. So here they wanted to make correct decisions and optimize the pineapple yield. So based on the index map, one can differentiate potential issues like maybe not enough moisture or disease or nutrient deficiency. And for pineapple crops, it's very difficult to walk on the fields and walk between the rows. So with the drones, it's easier, and you can focus areas on the index map that shows hotspots, and it's easier to know where you have to go, and it reduces the time. So again, on the right side, it's the RGB map of a pineapple field, RGB orthomosaic, and on the left side is it's the NDVI map. So you can see with NDVI, you can better understand the variability, understand that some parts are stressed, because the index maps is showing something that is invisible to our eye because it's beyond the visible spectrum. So by implementing precision agriculture here, Uh, so by the end of the year, uh, they had increased their gains, the yield by 15 to 20%, and operational cost was reduced by 30% because they could inspect the hotspots, and then they covered some of the areas uh, they saw in some of the areas the hotspots were due to sun damage, so they could cover those plants, pineapple plants, with mesh to protect sun damage. So using, it's not just Pix4D, it's any photogrammetry software or drone images. Like if you know what to do, it helps you increase yield, uh, reduce the input costs, and have a real effect. So you can also determine harvest time with these index maps. Um, so you can, it's variety independent. You can determine the harvest sequence and logistics, and you can also have good quality assurance of the optimal harvest. The next use case is crop protection. So crops need to be protected against pests, weeds, disease, insects, fungus, any kind of damage. Pest issues mostly they start at the edge of the field and then work towards the inside. So scouting is important, but it's good if you can see which parts are being damaged earlier in the season so that you can take actions before it's fully damaged or it's spread more. Well-timed and targeted treatments, they conserve the product and limit. Why Pix4D Fields? Again, routine flights can help determining developing issues that are being developed. Like you can understand that beforehand, and you can make zonation maps and prescription maps and use that as for variable rate application of pesticides or weedicides, fungicides for crop protection. So here is a image of white mold. So the prescription map approach enables growers to apply fungicides at rates that are appropriate for a certain plant. So Pix4D was used here to generate the maps, and then the map delivered prescription maps. Uh, Again, so at the red areas, since they were more damaged, more fungicides, the target rate. Uh, so the target rate was 0 because like there's no use, those areas are already dead. And then on the other parts, more target rate was used. So, so it can be applied in variable rate sprayers. So now I'll talk about the features for the next few slides. So you can, this is a Pix4D Fields dashboard. So you can have your projects, organize your projects around the field and farm and include key information like organization, crop type, crop variety. As I said, it generates maps really fast. I would recommend all of you just to try a trial or just have it and just try it. Like it's so fast. It just produces maps within 5-6 minutes. And for agriculture, it's really important that you have the maps very fast so that you can take decisions and not lose any time. Uh, then, as I said, we do this radiometric correction. That means you can correct for the sunlight, the cloud, and then you can compare your maps temporarily from time to time. We have this field boundary where maybe because like sometimes you fly and you get the roads and everything, but you don't want that because that will not help you in any way. You just need the map of the field so you can draw your own boundary and layers and trim the field. So we have an index generator. We have some available indices based on the number of bands you have, and you also have you can create your custom indices. As you can see, like you can create custom index to remove soil so that you just have the plants. So this is a pair field. in California. So it's zonate. After that, with the maps, index maps, you can create zonation maps. You can divide the number of zones between 2 and 7 classes. So if you think you need a more accurate zonation map or more classes, you use more classes. This is the prescription tool. So as I said, for seeding, for fertilization or fungicide application, anything, these can be used. And Pix4D gives an output in shapefile geotiff, which can be used with tractors. So you can export this map and use it directly in tractors, and you have to decide the application rate. So for the red zones, for the zones that have less vegetation index value, you apply nothing. And then for determining the rate, you need the help of an agronomist or the farmer, so that you can give targeted input at each zone. We have this comparison tool. Uh, so you can compare two maps at a time, and it's not that it has to be maps of the same project. You can also just import a geotiff, a map from another date, and compare it and see what changes have taken place. There's this annotation tool. So for these are plum trees. So you can go and, as I said, you can annotate, you can write what's, like you can point and write that what's wrong, and you can also write a description and also attach images from that area and know the location. So it gives you the latitude, longitude of that exact place. You can use the measurement tool. So the measurement tool is mostly used for insurance or other purposes, where you have to say, okay, this much area of my field was damaged. So it gives you an accurate measurement. Data synchronization, this is also something what I was talking about earlier. So you can sync the data. So you have one Pix4D account, Pix4D Fields account. So you sync the data, and if you log in with another computer, you will be able to see the project. There's this PDF report generator. So it exports a PDF report. So you can say what layers you need, and that would be in the report. Advanced layer visualization. So you can select the color mode you want. Like maybe in some color scale, you're able to see the variability better. You use that. Then you can use this histogram equalization tool and also change the index range. Like there is a slider, you can move that and remove soil or something that's not needed. Like you can change the range of the index that can be seen. It also gives you a GSD. So GSD is the ground sampling distance, which means like this one has a ground sampling distance of 2.34 centimeter per pixel. This means one pixel on this map is 2.34 centimeter on the ground. That's the measurement. But when you measure here with the measurement tool, it gives you the measurement on the ground. So it will give you the measurement in centimeter or meter or feet. So we also have this new feature where you can share your map like directly to John Deere Operation Center. So farmers using John Deere tractors and who have an account in this John Deere Operation Center can use this feature. So now I'll just show a demo. I have recorded a video. So this is a Pix4D Fields screen. You open and then create a new project. And as you can see, you can categorize them. You can import a folder of your images or just your images, not the folder. And then it will ask you if you want to do radiometric correction, if you want to change the ground sampling distance. Sometimes you might want to do that. And then you start processing. So when you start processing, it will show you the map, the mission planning on the screen. And here it just starts stitching. Like it will just place the images according to the geolocation, the GPS data, and it will create a map. like it's very fast, and it will show everything on the right side, the GSD and everything. Then you can import boundary or create boundary, remove the rows, and you can annotate, like maybe you like something happened, you say this is, you want to scout this part, you want to walk to this part of the field, so you write that. Then you can create the indices. uh, Now I'm creating NDVI, NDRE. You can change the color scales and use the one that best shows you the variability. And then this is a comparison tool. uh, you can change it again. I said you can also import map from a different project and compare, uh, and see, and also choose the index, like that which index shows the variability better. This is the zonation tool. So you can choose the number of classes you want, the quality. So this does clustering and will place similar vegetation index values together. So this is a nitrogen application proposal. This is what I was showing before in the other slides as well. You decide the rate. And then you can export PDF. You can say what I want in that PDF, and you export that. So this is a wheat field in Germany. And then this is the PDF report you get, which you can send to your farm manager or anyone, show the farmer, or for any proposal, you show this PDF report. This is the data sync. So you click on that and it will be synced to your account. So you open the project from any other computer, you will be able to see it and work on it. And then this is settings, where you, like you say you want to synchronize or not. You can change the data storage folder, change the language, change the units, because in US they use empirical, in India you use metric. And this is the farm management system, so it directly connects to the John Deere center, and you have to have an account in the John Deere operation center, and then you can use that directly in your tractor. And even if you don't have the John Deere operation center account, you can always export the maps from Pix4D and import that in your tractor. So you say what you want to export to the farm management system, and you go ahead and export that, and then later do the analytics in whatever you need in John Deere. Okay, so this was the end of my presentation. Thank you all for coming, for listening, and please let me know if you have any questions. I'd be glad to answer.
Okay. Thank you very much, ma'am, for delivering a very informative lecture and a nice presentation on decoding drone imagery with Pix4D. And your lecture will definitely be more useful to the students and young researchers who have joined this training program. So there are some questions in chat box and some have raised hands. So for the but with your permission, I will take a few important questions here.
Yeah, sure, sure.
Okay. First one, Dr. Siddhi Juikar from RIL has a question. What could be the NDVI value for bare soil and how it can be different from same area with properly grown plant soil?
So if the like if the soil has nothing, no weeds, like even if it has a little bit weed, it's okay. It will have a NDVI lower than the healthy plants or the place where plants are growing. And with that, like by the slider I showed, you can remove the soil, because soil will always have a lesser NDVI value or index value than the plants.
Okay. Thank you, ma'am. Then next one, Dr. Ajay Kumar Srivastav from JNKV has one query. He asked, soil characteristics also influence the NDVI value. So how this can be minimized?
So you're right. So everything, like the things you are getting with these vegetation index maps, like you just understand that these are stressed. Like something is wrong, these are damaged, but you or unhealthy, but you don't know the cause of that. So it might be the soil or it might be anything else, but that is why you need to go and scout in the field and maybe do soil sampling and understand why the value is less or more at that place. So you can never say the cause, like we haven't reached. You can do those with hyperspectral cameras, but then with multispectral cameras we still haven't reached that level where you can say that this is the cause of the stress. Like you have to go to the field and scout.
Okay. Thank you, ma'am. Then next, Mr. Thresh Dingore from MPKV Rauri has one question. How to do color selection combination in NDVI or Pix4D technology? Means for disease part or healthy parts.
So like it's the maps are like just not pretty colors. So you'll just see under the maps you'll see this histograms or the color bars showing you the value. So, and there are some color scales, so you can select any. It's best to select the one which shows the variability the best for your map, and then according to that, like you put that, and then you see your map and the histogram below. So maybe the red part is shows lower NDVI. So by that way, you'll understand. Okay, the red areas means lower NDVI, and the green areas mean more. But you should always look at the values below.
Okay. Thank you, ma'am. Then next, Mr. Arun Banerjee has asked two questions. First one, can NDVI demarcate between 2 to 3 different crops at the same field of view, and can it differentiate growth stages of the same crop?
Uh, So all the indices, like not only NDVI, but all of them, like some are like it will show the difference in crop growth stages because your crop canopy it's becoming more or but by the end it will if there's senescence again the NDVI will be less, but there'll be a change of NDVI throughout the growth stages. And what was the first question? Sorry.
And second one, what is the ballpark cost of flying drone per hectare in US versus Indian using census?
I am very bad at costs. I I don't have that much idea, but you can reach out and then I can tell you more. But yeah, Pix4D Fields, the cost of Pix4D Fields, I know it's 199 US dollar, so of monthly cost. And there is also a perpetual license. So one time license, you buy it and you are done. But it's just not Pix4D. It can be any open source software. Like it's not that I work for Pix4D, so I'll be advocating for Pix4D because I know it might be a lot for Indian pricing. So even if you have any open source software or anything, like you can use that and use these maps. Like drones are so very important right now. Like it increases yields and like if you see the uh, costs later, you will see that like for any farm, if you use drone and if you do not, you will see that there is a difference in yield maximization, cost reduction, input variables reduction.
Okay, thank you, ma'am. Then next, Mr. Lalit Upadhyay has a question. He asked, what is FCC? And then is Pixel 4D use true color of FCC? And what is the cost of software?
uh, I'm sorry, what is FCC?
First one, what is mean by FCC?
FCC, I don't think I wrote FCC anywhere.
Okay.
The
So,
FCC is false color composite. I think you
oh,
did.
sorry, yeah. Yeah, okay. I'm so bad at short form. So yeah, false color composite, the orthomosaics you're seeing in Pix4D, the RGB orthomosaics, they are false color composites. Like we are using all the bands. Like if a sensor has 5 bands, we are using all of them to create the orthomosaic.
Okay. Thank you, ma'am. And next, Dr. Suchitra Gupta has one query. She asked, can the color band will be different for different crops?
So yeah, so most of these cameras, the multispectral cameras, they come with normal, maybe red, green. Most of them, some of them have blue, some they do not. So it's red, green, because blue is not used a lot for plants, plant index. But NIR and reddish is used a lot. So most of the commercial cameras, they come with NDIR, NIR and reddish, along with red and green. So you can use, like, it's good not to use just one band, but use a index, like use some bands to calculate an index to see the variability better. And then yeah, like as I said, uh, like NDVI won't be able to show difference between like it might be better for one crop than another. So the vegetation index you are choosing, it depends on your crop, the growth stage, the soil type, and some other factors. So it's always better if you, for research purposes, if you create a number of index maps and then see which is able to show your variability or distinguish between the variation the best.
Okay, thank you, ma'am. Then next, Mr. Omji Nath from MPKV has a question. How Pixel 4D democrating the fertility zone in the field using crop response alone or anything else?
So it's just the, like, we are not doing anything new. So it's just the images. We are just doing a radiometric correction and stitching the images together. But it's, as I said, it's just not stitching. The measurements are intact. So whatever you measure, it will be accurate. It's not edge to edge stitching. Uh, so you get a map, and it's like whatever, it depends on the reflection of the crop, and we are doing radiometric correction, so you can compare the maps over time. uh, but like it's, you don't know what's causing the stress, or like what's causing the hotspots. You have to go to the field to check that out.
Okay, thank you, ma'am. Then one more last question.
Mhm.
Mr. Avinash Deshmukh from BrainSmart Solution has a question. How does Pixel 4D interact with decision making tool like data analytics? And is it compatible with multiple platforms?
It is, like, as I said, it's compatible. Like whatever exports you are getting, you get them in the formats we all use, like geotiff, shapefile, the things that are used in remote sensing and GIS. So there are a lot of features, and then a lot of features are also coming out. Like next, we'll have a feature where you can draw plots, and then you can export the statistics of those areas as CSV file. So there are a lot of features in Pix4D, but if you can't do something in Pix4D, you take the outputs and maybe use QGIS, ArcGIS, or whatever, or do some coding with Python, MATLAB, and do the analytics there if you need something more, which Pix4D Fields cannot do alone.
Okay. Thank you very much, ma'am, for answering to all the questions. Then, for the information of all the participants, there are still few questions and queries. We shall try to pass on those to the experts and convey you in the response of experts through WhatsApp group or email. Okay, thank you very much. Now, I would like to request
Thank you.
Dr. Mukund Shinde sir, organizing secretary of this training program, to propose vote of thanks. Dr. Shinde sir.
I think he has some connection problem. Okay,
Okay.
so you may go ahead with proposing of thanks. Huh?
Yes, yes, sir. Yes, sir. I would like to request Dr. Sachin Nalode, sir, organizing secretary of this training program, to propose vote of thanks.
Uh, uh, Thank you, Nandalal. Actually, so there is a problem in India to get connected with various locations. So it you can see Ma'am Chakraborty ma'am has given a lot of insights about Pix4D software. Basically, the software you have discussed is proprietary software for the knowledge of participants. He must have described it, and you should remember that that is proprietary software. You need to get a license. That may be lease, or you can get perpetual license for that. Uh, and she has explained a lot of things what you can do with imagery and how to process into useful data. Thank you, ma'am, for your presentation. And so we, from our side, from MPKV and all participants and the team of Center for Advanced Science and Technology, thank you very much for your presentation and answering most of the queries of participants. Few queries which are left over here, will be sharing those queries with you. Thank you, ma'am, for your participation.
Thank you so much. And anyone, you can always reach out to me through LinkedIn or any social media, and I'll be glad to answer your questions. Thank you.
Okay, thank you, ma'am. Then we now the start. We are now the start the second session of the day. The expert is respected Dr. Sunil Gorantiwar, sir, Head Department of Agriculture Engineering and Precision and Principal Investigator of CAST Project, and also the co-convener of this training program. So, firstly, on the behalf of CAST Project and Mahatma Phule Krishi Vidyapit Rahuri, I extend warm welcome to you, sir. And now I would like to request Dr. Sachin Nalode, sir, Organizing Secretary of this training program, to introduce Dr. Gorantiwar, sir, to our participants.
It gives me immense pleasure to welcome Dr. Gorantiwar for this lecture. Sir, uh, he is working with MPKV for more than 35 years of experience in he has done his postdoctoral research from Lubbock University with Commonwealth Fellowship. Also, he is visiting professor there nowadays. He has guided around 14 PhD students, 17 MTech students, and now they are still he is working with those research projects. And as principal investigator of Center for Advanced Science and Technology, he is looking after this whole project. Not only he is doing the single project, but he is having other projects from RKBY, and he is acting as a head department of agricultural engineering for university. He is working with other assignments like chief editor of Journal of um, research in Maharashtra Agriculture University Journal. He is working on various projects of government. He is active member of QRT team. So he is having a lot of experience, and he has done some research in uh, hyperspectral imaging, and specifically developed a few applications for irrigation scheduling, and he will be discussing around how to manage those irrigation part. uh, that was the participants request. He is going for this particular lecture. So this will be the introduction of his will take a lot of time, but so I am skipping all those things, and you may go to understand. You will get understand that he is having a lot of knowledge about this particular subject, and you will get a lot of questions. Those can be answered by Dr. Gorantiwar. Uh, Thank you, sir, for this particular
Okay.
lecture. Will be shortly giving that lecture. So,
Okay.
handing over to you, Dr. Gorantiwar, please.
Thank you,
Hello.
Dr. Nalaure. Sorry. Okay. Am I audible?
Yes, sir.
Yes, sir.
And is my screen visible?
Yes, sir. Visible.
Yes, sir.
Okay, no problems. Thank you very much. Thank you, Dr. Nalode, for introducing me to the participants. And before that, let me thank Chakraborty Madam for delivering excellent presentation, actually. So it was very informative. Not only informative, but you tried to clear many doubts, actually, okay, which we had in our mind. And thanks for your presentation. Now, this is in fact the unscheduled presentation, and sorry to many participants for this unscheduled presentation, but there were few queries regarding irrigation, and particularly from the participants from India. And we thought that let us have one session on irrigation, okay, to resolve as many queries as possible. But nevertheless, I hope this presentation will also be useful for the participants outside India as well. Okay. As the title of my presentation indicates, it is real-time irrigation water management. Though I mentioned here as real-time irrigation water management, but I will also be highlighting a few things on irrigation water management itself. Those who are already working in this field, they may find major part of my presentation as basic, actually, but still I request them to bear with me, because certainly there are some participants who need to know about the irrigation water management as well. Okay. I structured my presentation in this way. Maybe first I would like to narrate about irrigation water management itself for 2 or 3 minutes, and then what are the different components of irrigation water management. The first is how to irrigate. Okay, basically it deals with irrigation methods. Okay, and we had one specific lecture from the scientist from Washington State University on this, wherein he emphasized on sprinkler irrigation and also on the central pivot irrigation system. Okay, then it will be followed by the two components of irrigation water management, that is how much and when to irrigate. So when we say that the irrigation water management, it is how to irrigate, how much to irrigate, and when to irrigate. Okay, and then followed by the concepts of real-time irrigation management. It is weather-based, and in weather-based we have developed certain tools, mobile application and web-based application. I would like to describe those tools, and maybe I'll spend major part of my presentation on those tools. And finally, the crop-based real-time irrigation management. In fact, we didn't do much work on that, but we are developing the basic data which are required for developing the real-time irrigation management system based on spectral response. But as you noticed from the previous presentation and the presentations yesterday and the day before, Washington State University has done a lot of work on the real-time, in fact, I will say the real-time management of agriculture based on the spectral response. And it has also provided a lot of research inputs to take this work in countries like India and other developing countries as well. Okay. So let us come to the irrigation water management, actually. Okay. So when we say that irrigation water management, then basically it has 4 components. Okay. So the inner circle indicates those 4 components. Okay. One is the available water resources, then water budgeting of those available water resources, then allocation of those water resources, and utilization of those water resources. Okay. Basically, when we say that available water resources and utilization of available water resources, these 2 components, they are supply side and demand side respectively. Okay. And then water budgeting and water balance and allocation, in fact, they deal with certain equity and social and sustainable issues. Okay. but 4 together, that is the management of the available water resources, then utilization of the available water resources, allocation of the available water resources, and water budgeting and water balance. These are the 4 important components of any irrigation water management studies or irrigation water management, in fact. Okay. Now, in this case, we are specifically concentrating on if utilization of available water. In fact, if each of these components, if they have certain focus, say for example, in case of in case of utilization of available water, that is the demand side, if we use the efficient methods to utilize the available water resources, our water productivity may enhance by 20 to 30%. Okay. Of course, the other 3, I won't focus on other 3 components because those themselves, they are very vast issues actually. So let us focus on the utilization of available water resources. But let me summarize again that any irrigation water management has 4 components. Okay. One is the supply side management, another is the demand side management. In supply side management, we have to enhance the water availability, that is available water resources, and in demand side management, we have to utilize the available water resources properly. Okay. Besides that, there are social, economic, and environmental issues which cover in other 2, that is allocation and water budgeting. Okay. And as I already narrated, we'll be focusing mainly on the utilization of available water resources by adopting the methods of efficient utilization of available water resources. Then say, as already told, that we are in fact focusing mainly on the demand side, that is irrigation water management, and major component of irrigation water management is irrigation scheduling actually. Okay. And many of you know what is irrigation scheduling. This is means in fact, irrigation scheduling theoretically is defined as how to irrigate, when to irrigate, and how much to irrigate actually. Okay. So if we are able to answer these 3 questions properly, then in fact we'll be doing irrigation scheduling efficiently. And when we do irrigation scheduling efficiently, then many of the problems related to the water management will be solved. Say for example, if we irrigate properly, then maybe we'll save water. At the same time, we'll prevent much of our land getting deteriorated from waterlogging and so on. Okay. But the emphasis is that we have to have the proper irrigation scheduling, means we should irrigate properly, and by answering the questions how to irrigate, when to irrigate, and how much to irrigate. Okay. Let us see on the how to irrigate actually. How to irrigate is the way of application of irrigation actually. Okay. That is, it deals with the irrigation methods. Okay. That is surface irrigation method, subsurface irrigation method, sprinkler irrigation method, micro irrigation method. Okay. So the first question in case of the irrigation scheduling is how to irrigate. How to irrigate is the way of application of irrigating, and there are basically 4 ways which we'll be covering briefly in next about 10-15 slides. One is the surface irrigation, and in surface irrigation there are border, ridges and furrows, and check basin. Subsurface irrigation, we'll see what is subsurface irrigation. Then sprinkler irrigation. Then in sprinkler irrigation there are mini sprinkler, conventional, rain gun, central pivot, and then micro irrigation methods. There are drip irrigation method, micro sprinkler, bubbler, and subsurface drip. Okay, so we'll see each of these irrigation methods briefly. The second question is when actually. When to irrigate means basically when is the interval between 2 applications, or basically it is the frequency of irrigation. Okay, so if I irrigate my field today, then when should I irrigate the same field next time? So maybe it is today itself, or tomorrow, or after 7 days, or after 15 days. So basically it is the interval between 2 irrigations, 2 applications of water, or frequency of irrigation. Then how much means when I irrigate my field every time, then how much water I should apply, either in terms of depth of or volume. Maybe whether I should apply 5 mm of water, whether I should apply 5 centimeter, or whether I should apply 100 liters of water per tree, or 2 liters of water per dripper, or anything is related to the quantity. Okay, so thus irrigation scheduling means I have to decide which method I should adopt for irrigation amongst several methods which are available, which I have listed here as well. Then I have to also decide if I adopt or if I use any of these irrigation methods, then what should be the irrigation frequency by these methods, because irrigation frequency is not same by all the methods. Okay, so we have to decide depending on the several parameters that influence our irrigation management. Okay, and with every application of water, how much water I should apply to the root zone. So this is how much, that is the third question. Okay, let us see one by one how irrigation methods. Okay, now predominantly the surface irrigation the fields used to be flooded actually, and we used to call this as the surface irrigation method, but this is flooding, and we don't call this as the irrigation method at all. Okay, but predominantly historically in many countries the fields used to be flooded, and we used to call this as the irrigation, but we don't call this as irrigation, but it is the random application of water to the field without considering the topography, without considering the crop, without considering the soil, without considering the weather parameters that govern the irrigation actually. Okay, so basically we say that no to flooding actually. Okay, so it is not irrigation method in fact, but it is random application of water to the field, and water will move in any direction, water will percolate beyond root zone. Okay, there will be stagnation of the water, there will be water logging. Okay, and there will be a lot of disadvantages associated with this. Okay? So let the flooding be not called as the method of irrigation actually. Okay, so though some books classify this as the surface irrigation method, but the surface irrigation method is the method of applying water through certain layouts actually. Okay, so when we have proper layouts in the field, depending on the topography, depending on the crop, depending on the stream size which is available to us, okay, then it can be a surface irrigation method. There are major three types of the surface irrigation method. One is the border irrigation, another is the check basin, and the third one is the ridges and furrows. You see the topmost one is there is photo, and besides that there is one sketch. Okay, so this is the border irrigation method. It is surface irrigation method. In border irrigation method, what is done, we divided the entire land into the number of strips. Okay, and each strip is bounded by the ridges of maybe 15 to 20 centimeter height actually. Okay, so in between these two strips, two ridges, okay, there is a strip. The width of this strip will vary from 2 meter to 15 meter depending on the topography, and then we allow water to flow along this strip, okay, in downward direction, and as water moves ahead, some of the water will percolate into the root zone, as you see. The sketch just below that, and while some of the water percolates, some of the water will advance towards the end of the strip actually, and this is how the irrigation is affected. Okay, so but this is one of the layouts actually, and we call this as the border or border strip, means basically dividing the land into number of strips. Okay, each strip will have zero cross slope, but the certain longitudinal slope actually, depending on the type of the soil. Okay, and as we allow water into this strip, as here it is indicated through siphons, okay, water will move ahead. While water moves ahead, some of the water will percolate into the root zone. Okay, and some of the water will move, and while that water is being moved, it will again percolate down into the root zone. Okay, but then there are certain disadvantages associated with this. Then check basin. In check basin, what we do, we form the basins of certain size. It may be rectangular, it may be circular as well, round shape. Okay, and it may be square kind of the type. So typical basin size is say 5 by 5 meter, 10 by 10 meter, and we allow the required amount of the water, okay, to fill into that basin, and certain amount of the depth of the water is impounded into that basin, maybe 5 centimeter. Okay, and that 5 centimeter or 7 centimeter of water will percolate into the root zone. Okay, and the third one is the ridges and furrows. In this case, we divide the entire land into the ridges and furrows, and mostly the seeds are sown on the sides of the ridges, okay, or on the top of the ridges, and water is moved in the furrow actually. Okay, so basically those who are working in the field of irrigation, they all know that. Okay, but still the point behind telling is that these are the layouts actually. Okay, this is not the flooding actually. These are the layouts, and if we allow water to move over the land surface through this kind of the layouts, okay, then it is quite possible to achieve the reasonable amount of the irrigation efficiency through surface irrigation method as well. Okay, one of the speaker already told that it is quite possible to achieve the efficiency up to 90% through ridges and furrows irrigation method as well, and it is true as well. Okay, whenever in a country like India or in many developing country, we adopt the surface irrigation method, basically we don't adopt the proper layouts actually. Adopting the proper layout is very important. That is when we should adopt the border irrigation method. What should be the width of the border strip? What should be the length of the border strip? What should be the stream size? When we say that the check basin, then what should be the size of the check basin? And in ridges and furrows as well, what should be the width of the furrow? What should be its length? What should be its longitudinal slope? All these things are very important. And if we follow certain guidelines here, I have provided the certain guidelines here, which are available in many literature as well. Say, for example, this is ridges and furrows. Sorry that some of the words they are in local language, but nevertheless, you can understand the principle behind this. Okay, we have to decide, say, certain depth of water, say 7.5 or 15. This is the depth of water, and there are type of the soil. Okay, so first two columns, first column is for what we call as the depth of the irrigation, and the subsequent columns they are for the heavy soil, medium soil, and light soil. Okay, so you see that the length of the furrow depends on the depth of the irrigation to be applied, and at the same time the type of the soil as well. Okay, so such kind of the layouts, they are available for border irrigation and for check basin irrigation method as well. So we need to adopt those layouts, and then only we'll be able to get the proper irrigation efficiency. If we make certain alteration to the surface irrigation method, then it is possible to enhance the efficiency of the surface irrigation method still more actually. Say, for example, I have shown two photographs on the top, and I call this as the surge irrigation, because the surge irrigation is the widely practiced irrigation method in US and Australia. So in this case, what we do, the surge irrigation method is to be adopted for the ridges and furrows irrigation method. Okay, so in this case, basic principle is that let us irrigate the furrows intermittently. Say, for example, if I have to provide water to furrows for say 60 minutes actually, okay, then instead of applying the water continuously for 60 minutes, let us apply the water in 4 surges, and once time for one surge is say 15 minutes. Okay, so that is what I will do. I will apply water for 15 minutes, then I will stop for some time, maybe 15 minutes. Okay, then again I will apply water for 15 minutes, stop for 15 minutes. So this is the second surge. Third surge is again apply the water for 15 minutes, stop for 15 minutes, and in fourth surge again apply water for 15 minutes. Okay, so instead of apply water for 60 minutes continuously, I apply water in a surge, 4 surges, and surge time for each surge is 15 minutes. 15 minutes on time, that is water is being applied. 15 minutes off time, that is water is not applied. Okay, so in this process, what happens? In first surge, when water is being applied, then the soil particles, in fact, these soil particles, they mix with water, and certain colloidal solution is formed. And when water with the colloidal solution move ahead, so it will block the pores of the soil actually. Okay, and the water movement will be faster. In fact, what happens in any surface irrigation method, when we apply water, okay, then there will be a lot of deep percolation losses towards the head end of the surface irrigation method. You take border irrigation method, or you take ridges and furrows irrigation method. In surface irrigation method, we call this as the unavoidable losses. So to prevent these unavoidable losses, if we allow by some method to move water faster towards the head end, then we can reduce these unavoidable losses. And if we move the water in surges, as I told you, the surges will enable to block the pores temporarily of the soil, and water will move faster. Okay, so surge irrigation has that particular effect, and it has been found that we can save water up to 15% in case of the surge irrigation. But then again, this method requires a lot of techniques. What I told you in the to start with the surge irrigation, we have to apply water in surges, 50 minutes on and 50 minutes off. Then what we should do with that 15 minutes off time, because the flow will be there in the field. Then for that, what is normally done? So if we have 100 furrows actually, so we divide the field into 50 furrows on say right side and 50 furrows say on the left side. Okay, so first we allow water into the right side for 15 minutes, 50 furrows on the right side of for 15 minutes. Then we stop water and we allow water towards the left side for 15 minutes. Okay, so in this way we can apply the water in the surges without interrupting our flow of water. But for that we need the surge valve, which will enable us to do all these kinds of the things. Okay, but then there is scope for the researchers to develop the IoT based surge valve, which will do all kinds of the things actually. Okay, but then if we do this and if we make the entire system farmers friendly, still farmer can enhance the efficiency of the surface irrigation method by adopting the surge kind of the technique. Then locally, what we do, instead of irrigating all the furrows together, we irrigate the alternate furrow, which is indicated here. Okay, one by one furrows, and then there is skip furrow irrigation method as well. So for example, if I irrigate first, third, fifth furrow this time, next irrigation I will irrigate second, fourth, and sixth furrow. So this is called the skip furrow, and the alternate furrow means irrigating alternate furrow every time. So by adopting surge irrigation, alternate furrow, skip furrow, it has been found that we can enhance the irrigation efficiency of surface irrigation method by 15% actually. But then it needs certain kind of the technique. Okay. Then of course the land leveling. If we many times when we adopt the surface irrigation method, we don't give proper attention to land leveling. But if we have, and for surface irrigation method, adoption, land leveling is very important. And if we adopt this properly, say with the help of laser levelers, we can enhance the irrigation efficiency by 10%. Okay. Then measurement of water. In surface irrigation method, we never measure water actually. In sprinkler and drip, there is inbuilt arrangement to measure water, but in surface we don't do. But if we don't measure water, how do we know that we are applying the right quantity of water? So measuring of water is also very important. And it has been found that if we measure water, then it is possible to save water up to 10 to 50%, because we know the quantity of water to be applied if we measure water. Then distribution devices actually. Okay. When we use the surface irrigation method, we just break the bund and we allow water to flow into the layouts. Okay. And it has been found that 5 to 10% of the water is lost because of impounding of the water in the beginning of the layouts actually. But instead of that, if we use the siphon, which is shown on the top image, or if we use the gated pipes, which is shown on the bottom image, then we can save 10% of water actually. Okay. So either use siphon or gated pipes when we use the surface irrigation method. And then of course, in the beginning, I told we have to have the proper design and layouts of surface irrigation method, like we design sprinkler and drip method, but we never design surface irrigation method. So design those methods properly, use the proper distribution devices such as siphon or gated pipes, use some other techniques, say such as alternate furrow or surge furrow, and also at the same time, level the land properly as per the layout, then we are surely can enhance the efficiency of surface irrigation method as well. Then the next is sprinkler irrigation method. Why I have referred to sprinkler irrigation method, because it has one exclusive lecture was there. But just to tell the different versions of the sprinkler irrigation method. In fact, this is the conventional sprinkler irrigation method, which you normally see, wherein the spacing between the two laterals on which the sprinklers are mounted is 9 to 12 meter, and the spacing between nozzles or the sprinkler is 6 to 9 meter. So we call this as the conventional sprinkler. We operate the conventional irrigation system in shift, and normally it can save water to the extent of 10 to 25%, and it can enhance the it can enhance the yield by 10 to 20%, and its pressure requirement is around 3 to 4 kg per centimeter square. So that was also one of the questions. The pressure requirement for conventional sprinkler irrigation is 3 to 4 kg per centimeter square, or 30 to 40 meter. Whereas in case of the surface irrigation method, we don't need any pressure. Water moves by gravity itself. But in now other methods, we need the pressure actually. As I told you, conventional sprinkler irrigation method operates in shift actually, because if we irrigate entire land with the conventional sprinkler, the cost of the system will become more. It will become expensive. So to offset for that, that is, if we don't want to move the sprinkler system every time with each shift, we can have the sprinkler system on the entire land. Say for example, I have 1 hectare of the land. With conventional sprinkler, I may have 5-6 shift. That is, I may irrigate 0.2 hectare of land in one shift, and then after irrigating that land, I move my sprinkler set to the another piece of 0.2 hectare. Okay, but that is quite laborious. If we want to avoid that, we may not shift, and we can have the entire field irrigated by the conventional sprinkler, but it becomes expensive. So for that, the cheaper kind of the system is also available. We call this as the mini sprinkler, and farmers, they are using entire land without shifting with the mini sprinkler irrigation method. It needs less pressure actually. Its pressure requirement is up to 2 kg per centimeter square, or 20 meter, but we can operate this system without shifting, and it will be slightly cheaper as well. Then another is exactly opposite to that, rain gun actually. In this case, say for example, the farming conditions like in India or Africa, if we want to irrigate say larger piece of the land with one nozzle itself, then the rain guns are there. Okay, so I have shown here a rain gun intentionally for sugarcane. Because some may ask the question that if the height of the crop is more, what will happen? Rain guns, they are still applicable for that. So rain gun can irrigate, one rain gun can irrigate 1 hectare of area at one time. Okay, but it needs huge pressure. Its pressure requirement is up to 7 kg per centimeter square, and that is huge pressure. And at the same time, its discharge is as well. As you see, it needs the discharge from our stream size from 1.25 LPS to 25 LPS. It is huge. Okay, but it saves a lot of labor. But at the same time, we don't consider this as the efficient sprinkling system, because the spray is huge. There will be a lot of wind losses, drift losses, interception losses, okay, and the losses in the uniformity in application as well. Okay, but still, if we design it properly, it can give us the efficiency up to 60%. But its benefit is that without much shifting, it can irrigate large piece of land in one go. Okay? So if you see the kind of the nozzles, they are available. It is called, in fact, these are so huge that we call this as gun actually. You see how the gun operates here. Then the central pivot system, which has been elaborated by the previous speakers as well. So it consists of one big arm, and then there are the sprinklers actually, which are facing towards the earth surface, and this arm is moved in circles. So that's why when we see that these kind of the circles are formed, and the area of each circle may be 100 hectare or 200 hectare actually. So in one go, we can irrigate such a huge piece of land. And of course, these are not applicable for the small to medium land holdings. But when the land holding is say 2,000 hectares, 3,000 hectares, of course, this kind of the systems can become efficient. Okay. Then let us shift to the micro irrigation one. In case of the micro irrigation, as we say, there are 5 types: drip irrigation, micro sprinkler, subsurface drip, bubbler, and fan jet, out of which the drip irrigation system is quite popular. And why this is popular is not popular means it is becoming popular actually. Okay, because there are several benefits associated with the drip irrigation system. Okay, so why we should have the drip irrigation system? First thing is that it is related to the irrigation water requirement. There are 2 histograms. One is the green one, it shows the surface irrigation, and the blue one is the drip irrigation. Okay. In case of the surface irrigation, if the water requirement is 100 unit, in case of drip, it is only 50 units actually, because we save a lot of water. Of course, there are reasons for that. So there is water saving to the extent of 50% in case of drip irrigation method. With every drop of water, we can apply fertilizers, nutrient with drip irrigation method. So if we apply, if we have to apply 100 units of the fertilizer with surface irrigation method, then with the drip irrigation method, we can apply only 75 units, and there is saving of at least 25% of fertilizer if we adopt drip irrigation method. Of course, this is because of the inherent advantage of the drip irrigation method. We apply water in the form of drops, and we can apply fertilizer with every drop of water. And as water is applied efficiently in the root zone of the crop, fertilizers, they are also applied efficiently in the root zone of crop. Because in case of drip irrigation method, we can maintain the proper environment in the root zone. That is, proper environment means proper solid air and water ratio, and we can apply water frequently. We can maintain water at the field capacity at all the times, and also we can apply water in such a way that there is no stress to the crop. So yields are also more in case of drip irrigation system. If yields in surface irrigation they are 75, in drip will get 100, and there will be minimum 25% increase in yield. And also I have already told that we can save 50% of the water, and with that saved water we can irrigate almost the same amount of the additional area, and we'll have the additional benefit of 50% from this additional area actually. So there are several benefits associated with drip irrigation method. Some other benefits are that weed control. If in surface irrigation, if weed infestation is 100%, in drip it is only 50%. And labor requirement is also can be cut down to half in case of drip irrigation system, 50% labor saving. And more importantly, there is a lot of scope for the automation in case of the drip irrigation system. Okay, because nowadays we talk about the sensors, IoTs, cloud-based platform, mobile applications, and all those things. Surface irrigation method has only up to 25% chance of automation, but drip irrigation method has the 100% chance for the automation. And of course, as we can apply water intermittently, frequently, as per the requirement of water, exact amount of water, the quality of the product which we get from drip irrigation is also of the high quality. But with still so many advantages, why the adaptability of drip irrigation is poor in many parts of the world. One thing is that it is because of the high initial cost actually. Drip irrigation method, we have to invest heavily in case of drip irrigation system. Say for example, in India, if we want to apply the drip irrigation system for row crops, it costs maybe 1 lakh rupees to 1.25 lakhs rupees, and for orchard plantation it may be 50 to 60,000 rupees per hectare. And maybe initially for the farmers it may become difficult to invest so much, but still the governments provide financial assistance to begin with. So this drawback is being in fact removed at the institutional level. Then technical know-how actually. Surface irrigation methods, though that is also technical in terms of the layouts and all those things, but farmers they are using historically, and the knowledge from one generation to other generation is passed unknowingly, And so we consider that we may not need the technical know-how for surface irrigation method, but the knowledge is passed from one generation to another generation, and several generations they are adopting a surface irrigation method. But in case of the drip, maybe this is the second generation in many developing countries, and in fact not much knowledge has been generated, and for that we have to provide trainings actually. So in fact we organize such kind of the training. So of course this is the training for the students and faculty, but we also organize the training for the farmers on the adoption of drip irrigation method. And we also need all kinds of the support, actually maintenance support, operation support, and all those things. Okay, so in case of the surface irrigation methods which are being used historically, the farmers know that because the knowledge is passed from one generation to other. But in case of the drip irrigation method, we have to ensure that all these four parameters, okay, they are properly addressed for its higher adoption, that is higher adoption of drip irrigation method. So this is the typical layout of drip irrigation method. I don't want to go into detail, but you see what kind of the infrastructure we need for the drip irrigation system. There is a pipe network, there is a fertigation unit, there are filter unit, there is pumping unit. So these are the kind of the drippers, different kinds of the drippers are available. Some are online, that is mounted on the lateral, some are inline, that is within the lateral, some are pressure compensating, some are non-pressure compensating, some are low discharge, some are high discharge, and farmer has to select the proper dripper as well. Okay, and of course when we mount the drippers, then the laterals, they are on the field. The drippers, they are mounted on the laterals. Lateral is the pipe actually, which in fact laid in the field. So you see there is one lateral pipe for 2 rows of the plant. The farmer has to decide whether there should be one lateral per row, whether should be one lateral for 2 row, whether there should be one lateral for 4 row, or sometime for the orchard plantation there are 2 laterals for 1 row as well. Okay, so there are different kinds of the lateral arrangement. If we adopt this properly, then of course we can enhance the efficiency of drip irrigation method still further. The lateral arrangement for the orchard plantations, they are different. For orchard plantation, we may have the drippers arranged in loop or ring as well. Okay, then in case of drip irrigation method, there is subsurface drip as well. Okay? It is not sub irrigation method, but subsurface drip. Normally the laterals on which the drippers are mounted, those are spread over the land surface. Okay, but now there is also provision to install those laterals 10 to 15 centimeter beneath the land surface, so that we can reduce the evaporation actually. So instead of spreading the laterals over the land surface, if we lay the laterals some 10 to 15 centimeter beneath the land surface, then we reduce the soil evaporation, and in that process we can save additional 10% of water. And for the crops like sugarcane, or say for the multi-season crop, this system is quite beneficial. Then micro sprinkler. In fact, micro sprinkler is for the under tree irrigation. Actually, this sprinkler system is evolved for the light soil, wherein if we apply water by surface irrigation method, we lose lot of water. And if we try to apply water by drip, we need the number of drippers. Maybe 15 drippers or 20 drippers per tree are required when we use the drip irrigation system for the tree plantation on the lighter soil. So for that, under tree irrigation micro sprinkler system is evolved. In fact, this needs the pressure of up to 1.5 kg per centimeter square. Drip irrigation system needs the pressure of 0.8 to 1.0 kg per centimeter square. That is the lowest pressure requirement. Micro sprinkler needs pressure up to 1.5 kg per centimeter square. But one micro sprinkler can irrigate the entire root zone of the tree actually. So instead of 15 dripper, one micro sprinkler is sufficient. And also if we have micro sprinkler irrigation system, and if there are row crops in between two rows of the tree, this irrigation system is much better actually. So that was one of the question asked by one of the participants as well. So what kind of the system we should use when we have the row plantation in between tree? So let us use the micro sprinkler for that. Okay, so micro sprinkler not only for under tree, but we can use, say for example, onion, and for flower plantation, and for example for garlic also it is being used. Then bubbler irrigation, not much practice. Basically bubbler irrigation brings water with the help of tap to each tree, and there is one basin around the tree, and water is stored in the basin actually. So this is the bubbler irrigation. Then the last irrigation method is the subsurface irrigation. It is not subsurface drip, but subsurface irrigation. In case of all the methods, that is surface irrigation method, sprinkler irrigation method, and drip irrigation method, we apply water as per the requirement. In case of the subsurface irrigation method, we maintain certain water level in the root zone, and plant takes water as per the need actually. So this is the basic difference between other irrigation method and subsurface irrigation method. In other irrigation method, we apply water as per the need. So that is, we have to calculate the need of water, and then we have to apply that much quantity of water. But in sub irrigation method, we maintain the level of water 24 hours beneath the root zone or within the root zone, and the roots take water as per the requirement of the plant. So porous pipe, which I have shown here, is one such subsurface irrigation method. So these are the pipes of around 20 to 25 millimeter diameter. These are porous pipe. So these are mounted some 20 to 30 centimeter beneath the root zone. Then water level is maintained for 24 hours in these pipes by having overhead water tanks. Okay, and as the plant root takes water from the root zone, the water potential in the root zone will decrease, and as the water potential in the porous pipe is more, water will in fact move in the soil root zone. Okay, so this is how the subsurface irrigation is affected. Okay, now let us come to the second question now. So this was the first, how to irrigate. So I tried to briefly explain all the irrigation methods. How much and when, that is the irrigation scheduling. So once we adopt any irrigation method, then it is important that when we have to apply and how much we have to apply actually. And all this governed by the different parameters actually. Okay, so and here the entire technology can become complex, but then again our objective is to make this technology simpler to the farmers. Okay, because when we say that how much we have to apply, so it depends on the crop, it depends on the growth stage in which that crop is there, it depends on its root zone. Okay, it depends on the weather parameters, because there are many things actually. Okay, it depends on the soil type. Okay, so we have to take into consideration all these parameters and then decide when to irrigate and how much to irrigate. Before that, then when this is such a complex, then what farmers are doing currently? Okay, because farmers anyway they are applying irrigation water. Okay, then basically there are certain thumb rules and experience actually. Okay, farmers, they have experience, they can feel the crop actually, they can read the crop. Okay, and based on that they apply water actually. So we call this as experience. And over the years, the research have been done, research studies have been done in the universities and many institutes, and they have developed thumb rules for the farmers. Say for example, if they are adopting light soil or heavy soil or medium soil, okay, if there is wheat crop, then maybe if it is heavy soil, then irrigate every 4 weeks or give 7.5 centimeter of water every 4 weeks. If it is medium, give 6 centimeter of water every 3 weeks. If it is light, give 5 centimeter of water every 2 weeks. Such kind of the thumb rules have also been developed actually. So based on the experience or based on the thumb rule, the practice has been developed. Then many organizations have come up with certain kind of the ratios. One of the ratio is IW by CP ratio to guide the farmers to irrigate. Okay, are certain kinds of the factors actually. Okay, But then there are certain limitations to this. Okay, because if I want to use any kind of the ratio or something, I need the information at least of the pan evaporation actually. Okay, but then that information may be lacking. Okay, so all these results in under irrigation or over irrigation, because what in fact I want to say is that there are thumb rules, there are experiences as well. Okay, but those are not the exact actually. Okay, and because of which there will be mostly over irrigation or under irrigation. And if there are certain techniques actually, say for example IW by CP ratio are certain factors, but those techniques need certain kind of the data as well. Why data? That also we have to see. We'll see in next few slides actually. If we need those, if we have those data, then only we can apply certain factors and ratios properly. Okay, otherwise it will lead to over irrigation or under irrigation. Over irrigation will lose water, under irrigation will lose productivity. Okay, why we need all these kinds of the data? Here if you see, this irrigation is very much location specific actually. It is crop specific, soil specific, weather specific. Okay, because this is the water requirement. Water requirement of course will depend on crop. Everybody knows that crop growth stage as well. Okay, it depends on the canopy, it depends on the weather parameter. If I take example, say example of say banana crop. So if the banana grown in North India, banana grown in Central India, they will have the different weather conditions. Okay, similarly if I take banana sugarcane, they have the different characteristics. If I take the heavy soil, light soil, they have the different holding capacity. Okay, so there are many parameters actually. So because of these parameters, okay, this irrigation, that is how much to irrigate and when to irrigate, is very much location specific actually. Okay, I will take a couple of minutes to explain this, those who don't have much background of irrigation. Okay, basically when we say that the water requirement of any crop, the major component is evapotranspiration, because crop needs water only for one process, that is transpiration, not any other process actually. Okay, it is only for the transpiration. So we have to apply water into the root zone of the crop, which is needed to satisfy the transpiration process. But as we apply water into the root zone, and means we have to apply water into the soil. So when we apply water into the soil, there has to be certain evaporation from the soil. We call this as the soil evaporation. So this is evaporation plus transpiration. So water requirement is now evaporation plus transpiration, and together it is called as the evapotranspiration. Okay, so but the evapotranspiration depends on the weather parameters. Okay, so what is the temperature, what is humidity, what is rainfall, what is radiation, what is wind speed, all these parameters govern the evaporation process. And also transpiration process is governed by all these parameters together with the crop characteristics. Okay, so crop comes into the picture, crop growth stage comes into the picture, and weather parameters comes into the picture. And whatever water we have to apply into the root zone actually, that is soil root zone. And each kind of the soil has the different water holding capacity. Light soil holds less water, heavy soil holds more water. So soil come into the picture. So we have to take all these parameters into consideration, and then only we can decide precisely how much to irrigate and when to irrigate. So I already told that there are certain factors, there are certain thumb rules. Okay, and based on that we can develop certain maps. So this is the GIS based map for the central Maharashtra region for the crop sugarcane actually. Okay, so what we did actually, we analyzed the 30 years data of the different meteorological stations for different kinds of the soils, for different kinds of the crops in different growth stages, and we have calculated the water requirement by different methods as well. Surface irrigation method, drip irrigation method, sprinkler irrigation method with different efficiency as well. And we have developed the GIS based map. Means if whenever farmer wants to know the water requirement of this particular crop by this particular irrigation method, having this particular efficiency, and when grown on this particular kind of the soil, then farmer can refer to that GIS based map and pinpoint to that location and find out, okay, so today I have to apply 5 centimeters of water. Okay, and so we have several thousands GIS map for this purpose. But of course, there is a certain query kind of the thing, and farmer can easily access to the particular GIS map. But still, for farmer, it is very difficult actually. So for that, we have converted the maps into tables actually. Okay, so almost we have the tables for each taluka, because we cannot have infinite number of the tables for each village actually. So we have developed the tables for taluka level, for each crop, for each irrigation methods, and also for on each kind of the soil in local language, as you see here. So farmer can refer to that table. But the difference between GIS map and table is that in GIS map, for specified location we can know, and for the tables it is for the tehsil level or block level. So it is average value. Again, it is not the precise value, but nevertheless it is useful when we compare to the thumb rules or certain ratios actually. Okay, so these are the tables. Now let us come to the real time. So whatever I have told you regarding how much and when to apply, that is based on the historical data actually, average data, 30 years of the data. And you know that the average, the real time data always vary from the average data. So you take the typical current year. So in Maharashtra state of India, so in this region where we are working, our average annual rainfall is 550 millimeter, and in 3 months we have received 1200 millimeter rainfall. Okay, so the every year is different year, and it deviates too much from the average year. Okay, so we need not to depend on the average data as well. So we need the real time management. Real time management means location as well, because normally what we do, as I told you, in GIS we can have the information for the particular location, but still that is the interpolated one. Similarly, if we use the table, then this is the average for the tehsil or district, because we cannot have so many tables as well. Okay, and moreover it is based on the 30 years 40 years of the average data. Then let us have certain kind of the arrangement where we can have the real time of the real time water management. So for that, one important parameters, as I already told you, evapotranspiration is the important parameter which governs the water requirement. In fact, 95% of the water requirement component comes from the evapotranspiration. So basic need is to estimate first the evapotranspiration in real time. So we have developed one mobile app which we call as the Full-Agile mobile app, which enable us to know the real-time evapotranspiration at any location all over the world actually. Okay, and once we know that evapotranspiration at any location, then based on other characteristics of location, we can decide the irrigation scheduling. So for just for the evapotranspiration, we have developed the mobile app which we call as the Full-Agile mobile app. I will briefly describe that. So what is the mechanics behind this Full-Agile mobile app? The mechanics is that there are certain weather services. For example, in India, Indian Meteorological Department is the weather service, and all over world there are AccuWeather, OpenWeather. These are the weather services actually. Those weather services collect the data from their AWS, okay, and they can provide us the FTP protocol of their weather parameters. So what we basically did, we had the OpenWeather weather service platform, and as well for India, for few states, we got the access from the IMD weather service. So what they give us the weather parameters at different locations. Okay, they provide us the weather parameter at the different locations. These weather parameters are humidity, temperature, wind speed, radiation, and rainfall. Okay, and what we do based on this, we fetch all these weather parameters. Then we interpolate these weather parameters for the desired location. And when we interpolate these weather parameters for the desired location, then we calculate the evapotranspiration by Penman-Montague method or by any other method with the help of these interpolated weather parameters. And we come to know the evapotranspiration requirement for that particular location. Okay, so for example, so I want to find out the evapotranspiration of say some location near Bhopal in Madhya Pradesh. Then if I give the latitude longitude, or if I register that mobile app at that location, then all the weather parameters are fetched from one of the weather services at that particular location, and then evapotranspiration is computed, and then that evapotranspiration can be stored for further irrigation scheduling. So here I have shown you in short the flow chart of this. Okay, then what it does actually, basically, you see, this is how that mobile application will look like. There are different boxes actually. So as you go through all those boxes, there is one online method, offline method. Online method means that is used for the fetching of the online data. In offline method, if you have your own AWS, you can provide your own data actually. Okay, and then we have we can register the location, we can save the location, we can calculate the real-time ETR for the saved location, or we can calculate the blockwise ETR as well. Okay, then we can store that, and we can prepare certain kind of the reports actually. But the basic thing is that we can estimate the evapotranspiration in real time for the specified location anywhere in India or anywhere in the world as well actually. Okay, and by different methods as well. As you see the bottommost box, there are Penman Monteith, modified Penman, Hargreaves Samani, FAO24 pair evaporation, and FAO radiation method. So with all these methods, we can calculate the real-time evapotranspiration. And once we know the real-time evapotranspiration, the other tasks become easier actually. Okay, so these are certain screenshots for that. I will run one video as well. Okay, and this is available on Play Store. Okay, so I'll try to run video, and one of the program coordinators, please tell me if the video is visible or not. Is it visible?
Visible, sir, visible.
Now you see ETR, or you just first scan through the video. The location is being registered and saved. So basically what happens in online mode, at the desired location, it will fetch all the data, and it will calculate the evapotranspiration of today. Okay, and for next 3 days as well, because it depends on the forecast as well. And you can store all the evapotranspiration data by any desired method. Alternatively, you can connect your own AWS, or you can provide your own data to this mobile app, and this mobile app is available on Play Store. And this is basically it cannot be used by the farmers for irrigation scheduling, but this is the mobile app which researcher and students you can use to compare the evapotranspiration at different location, different periods of the year, by different methods and so on. And at the same time, if there are any irrigation advisory services, they can use this. Okay? This is available on Play Store. I stopped this video because the time is running fast. Then this is available as web-based application as well. Say, for example, if there are certain organizations, and if they want to provide the services to the group of farmers, then we have provided this on our website as well. Okay, so you will get the address of that website as well. But in case of the in case of the mobile app, the app is in resident in your mobile. You need not to register for that. This is one of the beauty of this app. And but in case of the web base, you'll have to register. And once you register, then you can get all kinds of the service for estimating evapotranspiration at any location actually. Okay. Then these are the reports which you will get from a web-based application. Okay, and at the same time, what we did, we have one online service as well. Say for example, I will show you. This is also available on our website. You can refer to this. Say here, it is showing for Rahuri. This is our headquarter actually. It is showing the weather parameters of today. And evapotranspiration by Penman Montet method. Say minimum temperature, minimum relative humidity, maximum temperature, maximum relative humidity, wind speed, okay, rainfall 0. This is for the previous 24 hours. Okay, and sunshine hour is 5.19, and reference crop evapotranspiration is 5.31. And if we move to some different location, okay, and then I get the parameters for this different location as well. Okay, and this is applicable, Mohsin, for entire world or only for India?
Entire world, sir.
Entire world. In fact, our students, they have in fact checked the values all over world as well. Okay, so it works for entire world. So you go to any point. For that particular day, you will get the weather parameters and at the same time reference crop evapotranspiration, not only for that particular day, but for next 3 days. Say for example here, 2nd October, 3rd October, 4th October, 5th and 6th is not. So for next 3 days, it gives us the values of the ETR as well. Okay, so this is one such real-time application for real-time estimation of the weather parameters actually. Okay, then based on that, what we do, we also developed the real-time irrigation scheduling app, which we call as the Fule Irrigation Scheduler. Okay, and in this app, what we have to do, in fact, this Fulagel is the engine of that app, because real-time weather parameter is must for that. Then in this particular app, we have provided the crop data, soil data as well. So in this case, what farmer has to do, farmer has to register his or her own field, because registering is important in the sense that latitude and longitude are important. Farmer has to register by going to the field directly, or farmer can give latitude or longitude of the field. Then farmer has to give the crop data as well. Okay, means what is the date of sowing, what is general crop period, and once that general crop data which is available with the farmer himself or herself is provided, other data we have stored. Say other data means, say for example, crop coefficient I have shown below, because for calculation of the evapotranspiration of the crop coefficient is important. So we have developed crop coefficient on the regional basis, and we have given the option of the FAO crop coefficient as well. And farmer has to give the soil data. Soil data means whether soil is heavy, medium, or light soil or very light soil, that farmer has to give. Farmer has to give the data regarding the irrigation system, whether it is surface, sprinkler, drip, and for any irrigation system, farmer has to give some details of the irrigation system that normally he knows actually. For example, drip irrigation system, what is the discharge emitter, what are the spacing between emitters, what are the spacing between laterals, and all other data. And above all, farmer has to give the pump details as well. Okay, so all the information which farmer normally knows, farmer has to provide in this app. And once all the information is given in actual operation, farmer will be told the information regarding when to irrigate, and at the same time at any irrigation date, okay, how much quantity of the water farmer has to apply, and for how many hours or minutes farmer has to operate the pump. Okay, so I wanted to tell detail, but by running one video I would like to stop, because both the mobiles apps, they are available on Play Store. And this Fule Irrigation Scheduler, that is scheduling service, is also available as web-based application. Okay, so I will run one video just for pomegranate plantation. So here farmer has to register first by giving the latitude or longitude or going into the field. Okay. Farmer has to give type of the soil. Say for example, pomegranate crop is given, and all other data related to pomegranate crop. Say for example, crop coefficients, and if it is drip irrigation method, what is its weighted area factor. All this data is inbuilt in this app. Say you can select the method. You can give parameters, or if you don't miss, it has inbuilt default values of the parameters, but if you want to change, you can change as well. And if you are using some other water conservation techniques, say maybe if you are using mulch, if you are growing in polyhouse, shade net house, okay, so that kind of the provision is also there by appropriately choosing the option. Okay, ETR is calculated by Penman-Monteith method in real time. It's calculating ETR for current day and next 3 days. Of course, farmers are user, they don't have to do this. This we have done for the explanation purpose. Drip irrigation method, we advise for light soil, go for daily irrigation, for medium soil, alternate day irrigation, for heavy soil, 2 days in between. So once on this advice, farmer has been given the information, say that give 53.6 liters of the water. System discharge should be 3.29 LPS, and system should be operated for 3 hours and 18 minutes. So this is how the farmer will get advisory actually. Okay. So farmer needs only two kinds of the information: amount of water to be applied and the time for which the pump should be operated actually. Okay, so this kind of the information is required, and this is available in local language as well, Marathi and English, but on request from many states in India, we're trying to convert that into other languages as well. Okay, and along with these two sets of information, this app gives us the other details as well if you want. Okay, so I stop this video here. And I stopped my presentation as well. In fact, I have skipped the real-time irrigation management based on the spectral response actually. Okay, but a lot of basic information and how to do, what to do, they have already been provided by the previous speaker. But before I stop, I would like to conclude that of the different components of irrigation water management, the demand side management is one such component. And in demand side management, another important component is the irrigation scheduling, that is how to irrigate, when to irrigate, and how much to irrigate. Okay, and we should know how to irrigate, which method we should adopt depending on our requirement, depending on our crop, depending on our water availability. Once we decide that, then we must know that for the specified irrigation method, okay, what should be our other irrigation scheduling parameters, that is when to irrigate and how much to irrigate. Okay, predominantly we can use our experience or thumb rules or certain average value, but now with the advent of technologies, because the technology is moving so fast that, okay, with the advent of technology, it is possible, and we made it possible real-time irrigation water management on the weather-based approach by developing the mobile apps which farmer can use easily. Okay, and at the same time, web-based service. This web-based service is for the organizations which can provide advisories to the farmers who cannot use the mobile applications actually. Okay, we did further work as well on this. We have connected this to the pump, and farmer can operate the pump from anywhere based on the time of operation which has been calculated by this Phule irrigation scheduler. Okay, but in nutshell, what I want to tell you that we have a lot of information available, lot of data available. If we make use of all this data, it is possible for us to go for the real-time and precision management of water. So with this, we can show at least up to 25% of the additional water and enhance the productivity at least by 10%. Okay, that is just by adopting the precision irrigation scheduling. I think I would like to stop here. Thank you very much, and I will be glad to answer to the questions of the participants. Thank you.
Okay. Thank you very much, sir, for delivering a very informative lecture and a very nice presentation on real-time irrigation water management. This is very important topic, and your lecture will definitely be more useful to all participants who have joined this training program. There are some questions in chat box. For the paucity of time, we may not able to take all the questions, but with your permission, I would like to take few important questions. Okay. First one, Mr. Rajat Sharma from Pantanagar has a question. Whether irrigation scheduling can have impact of pH, EC, and OC of soil?
Yes, naturally. Okay, because EC is the governing parameter in case of the irrigation scheduling. Okay, because if the EC of water or electrical conductivity of soil is more, we have to give the frequent irrigation actually. Okay, otherwise there will be a lot of stress on the crop. So that is governing parameter in irrigation scheduling. But whatever I have told in app is that the water is water which is available for the irrigation is irrigable water actually, not with the high EC water. But that change our irrigation scheduling. Means it also change our how to irrigate as well. Okay, say for example, if we have high EC water and if we go for the surface irrigation method, in case of the surface irrigation method, irrigation frequency you have to keep more actually, 15 days or something like that at least. And then towards the end of the irrigation period, there will be less moisture content, and because there is less moisture content and high electrical conductivity, plant will find a lot of difficulty in extracting water and it will be subjected to stress. Then in that case we have to go for the drip irrigation method. Also in case of the drip irrigation method, if high EC is there, we have to go for the more frequent irrigation. Okay, so it governs the irrigation scheduling definitely.
Okay, thank you, sir. The next, Mr. Ankit Kumar from Ranchi has a question. What is the hydrogel, and is it efficient in water management during crop production?
In fact, you know, hydrogel is the silica-based chemical gel, and in fact, it absorbs the water actually. Okay, I will say that in irrigated agriculture, hydrogel is not useful at all. Why, I will tell. And at the same time, however, in rain-fed agriculture, it could be useful. What hydrogel does, if we apply it, okay, and whenever there is rainfall, okay, soil will store anyway part of the rainfall actually. But if there is excess rainfall, that will be deep percolated. So instead of that excess rainfall deep percolated, hydrogel will absorb that, and then that will slowly release during the dry period actually. Okay, so in rain-fed agriculture, whenever there is long dry spells, okay, then hydrogel is useful actually. But in irrigated agriculture, I will say that we have to go for hydrogel. You adopt the precise irrigation scheduling, there is no necessity of hydrogel. For example, someone had asked me the question why that he wants to lay the experiment with the hydrogel and drip. I told him that if you design drip irrigation method properly, and if you schedule the drip irrigation in such a way that you apply precise water in the root zone, there is no necessity of hydrogel actually. Okay, I hope I answered your question. Hydrogel is useful for rain-fed agriculture to store the excess rainfall, rainy water, and release that water during the dry period. However, for irrigated agriculture, I will suggest you adopt the precise irrigation scheduling practices instead of using the hydrogel.
Okay, thank you, sir. The next, Mr. Fritz from Cameroon has asked two questions. First one, what can I get the actual amount of water needed by the plants in surface irrigation?
Can you repeat this?
What can I get the actual amount of water needed by the plants in surface irrigation?
Okay, in fact, water needed by the plant is in fact water requirement. water requirement is governed by the weather parameters and crop parameters. Okay, because evapotranspiration is the major component of water requirement, evaporation plus transpiration. Okay, and evaporation is governed by weather parameter, transpiration is governed by weather plus crop parameters. If you know the weather parameters of your location and also crop characteristics such as crop coefficient, then you can calculate the potential evapotranspiration with the help of weather parameters by any method and multiply it by crop coefficient of that particular growth stage. You will get the crop evapotranspiration, and that is your water requirement. So you do it for surface irrigation, you do it for any method, water requirement is same. Okay, irrigation water requirement will vary actually. If say water requirement of particular crop for the particular location is 10 millimeter, then surface irrigation will have the efficiency of say 0.6, then maybe you will have to apply 14-15 centimeter of water. But instead of drip, it may have the irrigation efficiency of 0.95, and we may have to apply the 11 millimeter of water. Okay, but the app which I have told you, full irrigation scheduler, it will enable you to calculate irrigation requirement, calculate surface irrigation, and at the same time drip irrigation for the different crops. Nandalal.
I think he got disconnected.
Okay, you can proceed.
Mr. Fish from Cameroon, he has asked that I learned that plant water requirement vary from crop to crop. How can I get the actual amount of water needed in intercropping system of farming?
In fact, you are right that plant water requirement vary from plant to plant, because the characteristics of the different plant is different, not only from plant to plant, but for particular plant during its different growth stage, it also vary. Okay, so in intercrop system, what you have to do, you have to calculate it separately actually. Okay, so if you have two intercrops, then you have to calculate for crop 1 separately, you have to calculate for crop 2 separately. And if you are using the same irrigation system for both the crops, then you have to convert that into composite water requirement. Okay, means for example, maybe crop 1 is on 1/3 area, crop 2 is on 2/3 area. Then you calculate for 1/3 area and 2/3 area separately. And if you are using surface irrigation or sprinkler irrigation method, then you have to calculate the water requirement composite, and accordingly you operate the system. In case of the drip irrigation system, you operate the walls separately in intercrop system.
Thank you, sir. Mr. Bhargav Alturi from Himachal, he has asked a question: which method can be recommended for hill top states like Himachal and Sikkim?
Okay, in fact, as told by the previous speakers, drip irrigation is the solution for all. Okay, so what I would suggest, you can adopt the drip irrigation method having laid laterals across the slope actually. Okay, don't lay the laterals along the slope. Okay, you can lay laterals across the slope, that is on the contours, and you can adopt the drip irrigation method. And if you have the water storage above, then you can use the gravity based drip irrigation system as well. Okay, so I will consider the drip irrigation system as the best suited for the hilly area, followed by the micro sprinkler actually. Okay, followed by the micro sprinkler.
Thank you, sir. Mr. Namdev Dhurve has one question. For tribal area, is there some some limitations to use that type of advanced irrigation methods because of poverty or other reasons? Which is the cheapest and convenient method we can use for paddy and pulses?
For paddy, of course, still we are advocating you can use for the surface irrigation method, depending on it is upland paddy or this ponded paddy. Okay, and which is another crop?
Paddy and pulses, he has asked.
Okay, in pulses, in fact, in tribal area as well, under in India under tribal subplan. Okay, so the lot of advisories have been given to use sprinkler and drip irrigation method in tribal area as well. Okay, you can use the drip irrigation method, but adopting the approach of deficit irrigation for pulses in tribal area. Okay, or I would like to suggest you to refer to nearby All India Coordinated Research Project on Irrigation Water Management. Okay, so AICRP we call in short. AICRP on Irrigation Water Management has the network all over India, and each AICRP has the tribal sub-plan program where they are implementing the irrigation methods in tribal area.
Thank you, sir. Mr. Ankushdeep has a question. Can we use micro sprinkler for horticulture crops like citrus?
Yes, we can use micro sprinkler as under tree irrigation for citrus plantation by taking proper care of its stem actually, but no problem because it will be more beneficial in light soil.
Thank you, sir. Dr. P. Bhuminathan from Tamil Nadu Agriculture University has a question. How to measure the evapotranspiration of tree crops?
Yes, yeah. In fact, measuring evapotranspiration of the row crops is itself is a cumbersome. Measuring, I'm telling, not estimating actually. Okay, measuring. Okay, for the row crop, we have to either grow this row crop in lysimeters, or we have to conduct the field water balance studies. Okay, but the for tree plantation, the option of lysimeter is totally ruled out because we cannot have such a huge lysimeters. Okay, but we can adopt the field water balance studies for measurement, not estimation. Estimation we can estimate with the help of available crop coefficient value, but for the measurement you will have to go for the field water balance studies, in which case you have to have the grid of vertical and horizontal grid, in which you have to measure the moisture content periodically to know how much water is stored and how much water has gone beyond the root zone, and you can conduct such kind of the studies. But for that you need grid based studies, and I will advise you, depending on the your tree crop, you must have the grid of 30 by 30 centimeter, okay, horizontal and vertical, and you procure the certain sensors or moisture meter, because gravimetric is ruled out. Calibrate that against the gravimetric method and measure apply the water and measure the water which is stored in the root zone, and also measure the water which has gone out of the root zone by installing the piezometer as well. So there is entire methodology available. The details I think will need a lot of time, but the name of the method is field water balance method, by installing the moisture sensors or moisture meter at the grids, and then noting down the reading, and then of course analyzing those reading.
Thank you, sir. Mr. B. Patil has one query. Is water loss more in crop of fallow land?
Sorry.
Is water loss more in crop or fallow land?
Water loss depends on the water application actually, and cropland, which kind of the crop you are growing actually, and at what stage, because in fallow land the albedo is 0.10, and in case of the cropland albedo is 0.24 to 0.26. Okay, so naturally in cropland it will be more. Okay, but at the same time it depends on the canopy as well, that we have to calculate. And what I will suggest you, you use our Fulegel mobile app. Okay, and in that mobile app you can vary the value of albedo actually, and and you can know the albedo of fallow land, you can know the albedo of water, you can know the albedo of different crops from the literature. You just change the value of albedo and you calculate the evapotranspiration. So you yourself can know that. Okay.
Thank you, sir. Last question from Mr. Nitin Palte, Dr. Babasaheb Sawant Kokan Kushi Dapuli. What is the effect of soil moisture along with ET to estimate water requirement?
In fact, when we want to we estimate the water requirement, then water requirement is function of crop and weather parameters, and soil moisture will come into picture when we have to apply water actually. Okay, so that will come into picture, but it won't affect the water requirement. Okay, for example, maybe water requirement, if I have calculated today is 10 millimeter. Okay. And if soil moisture is sufficient, then I may not have to apply 10 millimeter of water. Okay. But if soil moisture is not sufficient, I will have to apply that amount of water.
Thank you very much, sir, for your detailed lecture and answering all the questions. I think all participants got their answers. Thank you very much, sir. I will now request Dr. Sachin Nalaude for a formal vote of thanks. Sir, please.
Oh, thank you, Mohsin. Actually, this is only a formality because we are always in debt to our PI, who is always inspiration for all these training programs, and he is always guiding us all the team. Uh, Sir, thank you very much for your informative lecture. Basically, this will be very helpful to the students who are attending this lecture because you have covered every part of that irrigation management. How, when, how much, and how to calculate, and how to take a decisions also. So also you have given introduction to our mobile applications which are developed by MPKV Rahuri, and he will be always available to all the participants. So participants are requested to contact. They can leave their queries with our chat box, or they can send us mail, and those queries will be resolved. So thank you very much, Gorantiwar sir, and I hope participants are very much acquainted with the irrigation management and real-time irrigation management. So thank you, sir. Thank you very much.
Thank you, Dr. Sachin.
Mohsin.
Thank you very much, sir. There are some announcement. Okay, we have our last lecture at 3 p.m. Indian Standard Time today. Mr. Halchal Galgale from Kisan Hub UK will deliver the lecture on remote sensing. I have some announcement also. At 6 p.m. Indian Standard Time, we will all the participants are requested to submit the assignment on time as per the guidelines issued on WhatsApp group and time. Please note that responding to these assignments will be considered for issuing the certificate to the participant. Now, I will, with the permission of organizer and the co-convener, shall we close the session, sir?
Okay, no problem.
Thank you, sir.